Hello, and welcome everyone to this wonderful episode of Iron Beetle, which is remarkable because I think we are slowly inching to 100 episodes. It is not 100 yet. I think we are at like 95 or something like that, but we are getting there. Probably not this year, but definitely next year. So, what is Iron Beetle? Iron Beetle is a show where we do two things. On an object level, we learn how Tiger this modern financial database, works. But on a meta level, we try to understand better how you could build these kinds of systems yourself. Because the magic behind Tiger, well, besides all other kinds of magic, like static memory allocation, Ziga, search, deterministic simulation testing, is that Tiger is implemented fully from scratch. So it is a perfect case study if you want to know how you could implement something starting from zero as opposed to just gluing the libraries together. And a big part of implementing something from scratch is refactoring. So 5 episodes ago, or maybe even more, we started to look into the query engine. And the original plan was like, we learn how query engine works and then we'll move on, but that is very boring. So we started actually slowly refactoring the query engine, nothing big, just like, small adjustments to the signatures because, well, kind of like the code is hard to read, to be honest. With the goal of like, first of all, just better understanding what's going on there and also to improve the code for the future. Okay, so let me okay, sorry, mistake. Let's see where are we at right now. So if I remember correctly, what we did last time was to refactor. Yeah, last time we introduced the concept of stream. So if we look at our iterators, and let me avoid blinding you all, yeah, we kind of like extract this concept of stream versus iterator. So normally in Zeek, we are working with iterators where you call the next function and you get an item or a now, where now signposts the end of iteration. But when we are doing query engine, what we are iterating ultimately is data on disk. And reading data from disk takes time. And because Target is top-down asynchronous, that time needs to be modeled explicitly. So query engine operates on streams which return an item, a null, or a pending value. And pending means that, hey, actually, this stream needs to read some data from disk. So pending means that, hey, take a pause and come back later when I will be able to tell you whether I have more items or not. And where we stopped last time and where we want to start this time is this key-way merge iterator thing. So key-way merge takes key streams or iterators and produces a single iterator or stream which, like, merges. Well, it takes k sorted streams and produces one sorted merge stream. And the problem here, what really bugs me about this API, is that key-way merge itself doesn't do any input-output. The nature of key-way merge is that it is not asynchronous. And yet, because it has to work with the streams, we have to model this. So the functions, it works as string functions. They can return pending. And that means that when we use key-way merge to merge iterators, we get to use a Warsaw API because we kind of have to pretend that our iterator is a stream, that our iterator can block, while in reality it actually cannot block. So I'm wondering if there is a way to write key-way merge such that it is kind of agnostic about the streaming nature of the work here. And I think what I want to do this, so let's see, so kind of what I want to do this is to essentially, so this is pop is public API and it returns values. And what I probably want to do is that rather than popping values, I would rather say, can we return an index, no image. Oh no, no image. Why there is no image? Let me quickly okay, no, so this I feel like I promised. So there is some problem with Twitch for some clients. Like some people say that, hey, I cannot see anything on Twitch, and some people say, but no, I can see everything. And I'm not sure what's the deal here. But given that some people can see stuff, that means that it's not problem on me uploading the stuff. And again, in any case, as usual, everything is going to be uploaded to YouTube, so this is not going to get lost forever. Okay, so where we are? Yeah, so kind of my idea here basically is to say that, hey, we have pick index and maybe we have pop index. And maybe we could handle the stream aspect of this externally. We'll get back there just in a moment, but there was a question in the chat. Do we have any kind of slides that talks about how do we test performance? Like how do you avoid performance regressions? Good question. We don't really have good talk there, for the simple reason is that we don't really yet know how to test performance in a good way. I've recently wrote something. What I know here, let me check. 4 months, Matplotlib. Benchmarking. Yeah. So I recently wrote that comment on Ziggy about what I know about benchmarking, but honestly, it's not too much. The way we approach performance at Tiger so far has been on a more fundamental level. Yes, significant part of performance is taking a pure profiler, taking your instruments and looking at the cache misses and instruction counts per cycle, using SIMD optimizations, all that good stuff which you think about performance. But that is the icing on the cake. The actual performance is in the architecture of your system. It's kind of you could be on a bicycle, or you could be in a car, or you could be running. And I mean, if you train hard, you could run faster, and maybe a good runner can outrun a bad cyclist. Probably Usain Bolt can outrun me on a bicycle. But the fundamentals are there. And what we've been focusing performance-wise for Tiger so far is building a jet engine, while not necessarily optimizing the jet engine to be the optimal jet engine. This is changing. We actually now have Toby on our team who is starting to look into more performance-oriented code, and that's actually that's actually why this Kiwi merge thing is the smart loser tree data structure, and not a simple Kiwi merge using a heap which you have learned in school. But we haven't yet. I mean, it is on our to-do list. Hopefully we'll do this really soon, but we don't have super great infrastructure for tracking performance other than just writing some random benchmarks on GitHub public runners, which of course doesn't give us higher resolution. Okay, so yeah, so this is kind of the idea. My hypothesis is that if I disentangle this pop function into, hey, this is the index which needs to be popped, and then, hey, here I'm popping the index, then I think at this point we can handle a synchrony. But well, let's see who even uses Kiwi merge iterator type. So scan and table memory. Wait, I think scan3 also should okay. Oh yeah, because it just qualified. Well, this is why it is important that you are consistent in the way you write code. You see, sometimes you use it unqualified and sometimes you use it qualified, and that makes kind of hard to grab for usages. So let's actually do this way. Okay. So now we SST still not getting this. Why we merge? Okay, because we also have break. Wow, okay, it's still better, but not perfect. Okay, so this is our, and what are we providing? We are providing next and pro, right? So it's country. Also, we are providing next and we are providing pro. So this is probably the right API. And let's see how it works here. So what I want to do here essentially is I want to say, okay, let's actually just pick index and then pop index. And here I want to say something like, hey, if the streams so where are the streams? Let's see. Okay, so only if scan merge level pop. Okay, so I think I want to say something like, hey, if level needs data, self state equal needs data. So this is what I actually want to write here. Yeah, here it's going to be like just return value. So yeah, okay. This I think is so maybe we don't need pop. Maybe we don't need push index pop index. Maybe it could just be pop. Pop with index. Okay, we merge its readers. Value index utility. Okay, and here, to do. So what we are going to do here is that we will say result with index return result.value, and yeah, so like level index is going to be result index, and then if something happens, we do the thing. Okay, yeah, this kind of like this style of API makes more sense to me, because that way we don't actually require the merge iterator to know anything about like linear orders. So let's see. In the level, we have peak and we have probe. So we could say that, hey, if level peak pendant, then we say that it needs data. Okay. Okay, so now the question is like, so we have like this refactor which sort of maybe works. And the question is like, do we actually want to do this refactor? Like, is it worth it? And the answer here is like, if you don't try, you wouldn't know. So we are going to just like, go and try it. Okay, let's try this. So we are going to change everything. So string peak is going to return like, normal. Okay, so there is no pendant anymore here. Okay, what is load? Crew calls load. So we are going to I think we aren't going to have like a load in state. So return. Okay, well, what did we have before here? Wait. Okay, yeah, so we could actually say load to do fix ones should be fix me, fix name. Fix me, there is no picture. That's, how can there be no picture? Okay, yeah, so like folks who have problems viewing video on Twitch, I don't know what's going on. I think this affects only some people. And because some people can actually see the video, that means that the problem is like somewhere like on the Twitch side, somewhere. But I will try to double check that for the next stream. But in any case, the video is going to be uploaded to YouTube. Okay, so I think we are going to have the load here. So now this cannot fail. Okay. When do we, okay, we always keep state for each written. Okay, then and the pop is going to be just self pop with index or else return now value. Then we don't need this. And then the next result of index tracked. Okay. So next is going to return of index. Deduplicate. We have options. Okay, but this. Oh no 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 this duplication. So I was thinking that hey, we kind of like do one motion at a time. Like we have like a bunch of streams. We say okay, so we popped one value. And now we're fine. But actually, well, okay, maybe this is fine. Maybe this is fine. Like, so like, so if I want to remove a duplicate, that means that like, hey, if we're popping a key and it is exactly the same as the previous one, then we drop it. So also like, does this really belong to, well, okay, so first, are we going to, yeah, so we are going to duplicate here. But it's kind of like tough. So so basically, like my worry here is like with this duplicate detection, could it be the case that we need to pull one stream twice? And sort of feels like maybe duplicate detection should be handled elsewhere. So let's see who even needs the duplication. Kiwi merge and Scanway merge, and well, Kiwi merge is just the tests. So Scantree and we don't want R. This is painful. We don't want to write the duplication code twice. I mean, we could say that, hey, let's just write the dupe on top, but okay, this is mightily annoying. I don't really want to do this. Can we make this better? Do we even need stream abstraction? Well, we do need stream abstraction here. Okay, this is annoying. Yeah. Can we I don't like this at all. It feels like it should be like sound like much simpler. Oh, people want a Z course. Well, maybe one day, but who knows? Well, I mean, okay, yeah. Let me say this way. So I'm officially making a promise that I will do a Zeek course as soon as Andrew Kelly releases Zeek 1.0. So you don't have to pester me about releasing Zeek course. You have to pester Andrew Kelly about releasing Zeek 1.0 because obviously, while the language is unstable, the value of the language course is diminishing because it is not reusable over time. Okay. So I'm wondering, can we maybe even flip this around? Do we need like peak pop precedence type? So how does it work? So when we call and get a next item, swap nodes. And in the node, we have key, stream ID, and Sentinel. Just kind of like wondering, like, maybe we don't. Yes, this is this is one spell. I was recently on the concert. They were awesome, although Sinistru was actually better. Okay. So I'm wondering, like, can we flip this around and instead of this, just say that, hey, keyway merge always works with like, so basically like pass array of values there, and then it kind of like says, so, and values maybe, they may be even nullable. And then we could drive this thing saying, hey, we got new value. Okay, so kind of like push thing. Because yeah, okay, but the question is like, are we duplicating these values? Like, who actually stores those data? Because we probably only want to duplicate the keys, right? Oh, actually, do we even? Yeah, that's curious. Okay, so folks, we aren't actually using values here at all. So what if we say that what is happening here? Oh, okay, yeah. My layout was wrong. So what if we, well, okay, another idea. We just say we have only keys. We don't have key from value. Stream tick returns key, and there is no string pop. It is on the user to call string pop. And we actually return stream index here. Then we okay, so this actually returns next const index next. Index if e equals pref, then we say that key popped equal key, but we return the index. Okay, this might be okay. Well, let's see. This is not something I originally planned to do, but that actually feels like it might, like, you know, simplify the refactor somewhat. Okay. Hmm. Wait. So I don't want to actually pop this. I just want to return. key. Well, I mean, I don't even have to return because I have this data in the contender, I think. Then, okay, this deduplication again kind of like fails me because so the idea here is that pop just returns you an index, and then you actually have to advance the iterator. But that means that you need to account for duplicated keys yourself. And we kind of like don't want to do this. Okay, this is okay. API design is hard. API design is hard. Okay, so let's. Well, I mean, if we do not make any progress today, that is also okay, because not making any progress is also part of a program. It's not like, you know, you always go and like code and it works. Like sometimes you realize that that thing that you were trying to do because you thought that the thing is easy is not actually easy. So here we have like a bunch of streams. So, okay. Okay, let's. Let's assume we don't have duplication at all, because it kind of like makes it hard. What would it make for? So how we then are going to create key emergence iterator? We aren't going to need the pop function. We'll have to do the precedence function. Okay, and then we return. Okay, so there is no pop, and we don't do duplicate, and this also doesn't have to know anything about value, and we also do not need key from value. So this is all fine and dandy, but how do we do this? So whenever, oh wait, this kind of like doesn't make sense, I think. Oh, no, okay, this is, this doesn't make sense. We set it only once, okay. And then what do we do with merge iterator? we say pop, and well, let's revert this. What we So here we have a little different state machine. We have something like string ID equals literature or else now. So yeah, so this is okay. This is my piano. If I write this like the duplication loop here, like just tiny duplication loop, it kind of like makes sense and simplifies the iterator interface massively, I think. But it doesn't really. Wait, how does this logic works? So okay, we kind of like so essentially, okay, so so annoying. It's kind of like, well, okay, what if we pursue maximalist design? What if we don't pass in streams at all? So what's going to be we launch sans IO? So we are going to, I guess, feed key self link to the key is void, and then we will have which returns as 32, and the contract is that after you call next, you need to call fig key back, and then we also will have merge sans IO dedupe. But that's okay. There is going to be some so the duplicate, and essentially here we'll have, okay, yeah, I think I got it. Yeah, so we'll either yield this index, or if this is a duplicate, then we will have to discard it. So So essentially the loop is going to be like we have like this iterator, and then we say next, and then we say feed. So it gives us backstream ID, we give it the next key, and we return the previous key. And that sort of makes sense, but also it's kind of like painful. Oh, maybe we could write stream adapter here. So or maybe it's just simpler with callbacks. Okay, kind of like really bugs me. Okay, yeah. So maybe this is it. So we have like peak mean, and then we have advanced mean, and then the call side is going to decide. Okay, so it is the worst stream. Like really, like I've been just poking around in various places without making any progress for like almost an hour. And it's kind of like a question, okay, should we persevere, or maybe let's just say that, hey, this is the best thing we could do. And it sort of feels that, yeah, this is maybe better. So, oh, yeah, like zero lines of code written. But okay, imagine let's quickly just imagine this API. So let's call it Kiwi merge 2. Just Kiwi merge. So it's not going to be an iterator. Time. It's not going to need context, only the key. And we still, well, I mean, do we need Steam precedence? Wait, okay, how does Steam precedence works? Okay, this is curious. Precedence. So we don't use scan here and like it is linear here. Okay, merge. No, illustrator type. Okay, so we actually so we actually don't need string precedence. Okay, so we'll have more time key type. Wow, lose a tree type. Oh, okay. I think I got it. So I will implement a simple loser tree. Then I implement key emergent iterator type in terms of loser tree, maintaining the same API. And then I will see if I can actually use the loser tree directly by passing key emerge, because this is okay. So we have contain key. And like, folks, this is all linear. You don't need anything else. Okay, so let's. Okay, so let's see if I can do this. So this returns a type, and we are going to return a struct. We'll need all this stuff except keep hoped. Direction is, yeah, direction sadly is runtime. We don't need context. We do need node. So let's precedence A less than B and C precedence. Okay. It seems like it just okay. It just should be A less than B. Okay. So true means A loses. which doesn't make sense. Oh, this is backwards. This is exactly backwards, right? True means A loses, but if we return true, then okay, let's see how it is used. It's if competitor wins, so it's kind of like if competitor A beats competitor B, then competitor B becomes a loser. Okay, so this is exactly backwards. Okay, so let's maybe okay, so change of plans. Yeah, I'm not sure if like such like deep refactoring streams are interesting, but like the purpose isn't like to show what's interesting. The purpose is to like show how this thing actually works. So I think it is like this like live coding is actually like variable. So what I'm going to do today is to say like to call today to submit just a single uh, command clarification pull request. But then we do actually have a plan for the next week. The plan for the next week is that we are going to extract tree of losers as a Santa.io algorithm, and I think I did make good progress there. And then we implement k-way merge interface in terms of that tree of losers implementation. And then we will see if we could actually can get rid of that interface. Okay. Um, uh, Sentinel. The Sentinel always loses. Wait. Wait. Was it fixed? True means A wins. Well, true means A wins. So I may just completely wait. This says loses, but this is wins. When when this was changed. Is that horrible that we aren't going to make like 0 pull requests today? This is going to be horrible. Well, no, Toby. No, you fixed you. Ah. So okay, this is going to be Ah, absolutely like most empty, most useless iron middle stream ever, where we did not do anything at all. But I think we do have. Okay, so let's start Okay, branch. It's going to be free of users v2. And we are going to have here tree of users type. No precedence, no values, no nothing. And this is what we are going to do for the next week. Yeah, but again, sorry, not sorry, but this is actually how like my programming work looks like. I mean, I seldom make progress. Most of my time is like, figuring out which progress are we going to make. Okay, so let's call today and see you in a week at 5 p.m. UTC live on Twitch, and I will double check if my video is working on Twitch. Goodbye.